Hello, welcome to the simulations video. So this is me trying to help you visualize a little. We'll do a little activity possibly in class. Okay. So we have a 4-color spinner here that I brought into school, and every person got one. Each person got their own spinning wheel, and they spun it 50 times. And they kept track of how often red appeared. So they did the spinner and they went around 50 times. They went around and around and around, okay? 50 times. Every time it landed here on red, they counted it. So you can see here, what we have here is each dot represents one person's sample proportion. So this is, Steve, this is Joe, this is Madison, this is Chloe, etc. So each one of those dots represents that person's sample proportion. And what, if you remember what that was from the margin of error video, is every time, like if I got, say, 10 reds, I spun it 50 times, that is my probability. That's my mean proportion. They're the same thing. So each one of those dots represents that. So you're either going to see it like this, where each dot is a sample proportion. So each one, all of these numbers down here are always less than 1 and greater than 0. Okay, they're always a decimal. It's always a probability. Or you're going to see a how many. So we could have also made it by graphing the 10, just knowing that each one was out of 50 is what we would have to know. So each one of these is a one person's mean proportion, how many they actually got when they spun the spinner. So what I'd like you to do is put each one of these guys into your calculator. So to help you out, remember, this number down here is your L1. This up here is your L2. So this is 1, 2, 3, 3. Just so it's quicker for you, because I had trouble reading these, but I'm 100 years old, so whatever. Okay, so take a second and plug these in while I finish writing these down. So this is a 10, this is 12, 18, 16, 7, 7. Okay, this is a good idea to do even when you have to do something like this. Because if I have you do the mean proportion of something like this, but you, I don't know, counted 17 here instead, everything is going to be wrong. Okay. But if I see that you put a 17 there, then I can see that, oh, maybe they did do it right, and I can see what the correct answers would be. So this is just a way of you showing me you know the numbers and maybe just messed up one or so. Okay, what is the smallest sample proportion? So the smallest would be the lowest number. What's the highest? 0.4. That means 40% of the time the person got a red. This one means 10% of the time the person got a red. Okay, what one occurs most often? Remember, that's the mode, and that's this one, 0.24. All right. So notice up here, I did note that here, round your answers to the nearest thousandth. I'm probably not going to see that when I move this down. Okay, so I'd like you to put these in here and fill in the mean and the standard deviation. Okay. All right, so I got 0.247 as my mean to the nearest thousandth, and 0.062 for the standard deviation. So how does this mean of the sampling compare with the population proportion of 0.25? Like, what did you just say? What are those words? You are crazy, okay? What I'm trying to say, this is our sample. We had a bunch of people do it. But if I were to actually say, what is the probability in that spinner of getting a red, the probability of getting a red is 1/4, right? Because there's one block of red and there's a 4 total. So this is the actual probability, which is 0.25. So how does 0.25, which is what should be the actual mean and the probability, like all that stuff should be 0.25. Okay. How does it compare to our mean, which is 0.247? How does it compare to 0.247. Well, it's darn close. Darn close. Well, I don't know if, I guess maybe darn isn't a good word to use. Very close to the population. Okay, so ours is probably pretty good of a sampling. If you would happen, what would you think would happen to the variability or the standard deviation of the distribution? So meaning what would happen to our number here and here, to the standard deviation and this, the mean that we created, if instead of 50 flips, we would have everyone do 200 and count the reds in 200. What do you think would happen? Well, what would happen is that the standard deviation would be smaller. What that means is the variability would decrease. I mean, it wouldn't vary as much. And the mean, I'm just going to do this, would be closer to the actual 0.25. It's pretty close right now, but it would be even closer. So the more samples that you choose, okay, not necessarily the more people, but the more times you do it, the closer to the actual mean you're going to be, always. That is what the bell curve is all about. Pretty darn exciting. All right, so what we have here is just a few more questions answering just how many people stayed after. So this is just your one variable statistics. Just answer that question. You should be able to. So correct. So you should have gotten 100. There are 100 dots. The day I have 100 people stay after. Probably Regents review. But anyway, use the previous work to determine the margin of error. So remember, our margin of error is 2 times the standard deviation. So it's 2 times that's a times 0.062. So our standard deviation is going to be 0.124. We know that is the formula. If I have the mean and the standard deviation, I'm using that one. I don't care what mean proportions I've got. Okay? Estimate the confidence interval. So what my mean is 0.247. So I'm going to add or subtract 0.124 to get the first part of the interval. And then I'm going to add 0.124 to get the others. So I'm going to get 0.123 and 0.371. So my interval, remember, these are proportions. You know, these are percentages. If you multiply it by 100, if you multiply that by 100, you will get the percentage. So this question down here says, Nathan was playing a game with his mom with a similar spinner. He claims that his spinner wasn't fair because he only got 5 out of 50 times did he get a red. Okay, so the problem with this is, was Nathan's spinner fair? So he's upset. He thinks he should have, won or whatever. So what we can do is exactly what we did yesterday. So one of the ways that we can just take 5 divided by 50 and see that 0.10 is not in the confidence interval. So it happens so rarely that so the spinner is probably not fair. Okay, again, you could also take the 50 times and multiply it by 0.123 and 0.371 and see if 5 lies between it. That's the other alternative to doing that, which is why I mentioned this piece. Okay, so it's exactly what we... All right. So have a great day.